Okay, now let's suppose a test charge is moving under the influence of electric field of several point charges. Test charge Q naught and it is moving under the influence of several point charges. Q3, Q2, Q1. The total field at each point is the vector sum of the fields due to each individual charges and the total work done on Q naught during any displacement is the sum of the contributions from individual charges. But from equation of potential energy, we can conclude that potential energy associated with Q naught would be the algebraic sum, not the vector sum. Oh, it would be a sum and so on. So point charge Q naught and the collection of charges. Now if Q naught move from, and let's suppose this charge is at point A. If Q naught moves from point A to some other point B, then potential energy will be given by the same formula, but the distance R1, R2, R3 of Q1, Q2, Q3 will be taken with respect to point B. So the work on charge Q moving from A to B is equal to the difference of UA minus UB. The point to be noted is potential energy is also involved in assembling these charges. If the charges were at infinite distance before they come together, the distance between Qi and Qj charge after assembly is, let's suppose, Rij. The total potential energy is the sum of the potential energies of interaction of each pair of charges. It can be written as so sum extends over all pair of charges. I is equal to I is equal to j because it means the charge is interacting with itself, so we didn't take this thing. I is equal to j. I is smaller than j, we take this thing because each pair can be counted only once. Okay, so now let's solve one example. It will give you a better understanding about the concept of this electric potential energy with several point charges. Okay, so 2 point charges are located on the x-axis. Q1 is equal to minus E at position 0, Q2 at E at position A. So first part is find the work that must be done by an external force to bring a third point charge Q3 from infinity to position 2A. And the second part is find the potential energy of the system of 3 charges. So this problem involves two phenomena. First, the relationship between the work done and the charge in the potential energy. Second, the expression of potential energy due to collection of point charges. So let's draw the diagram based on the problem statement. So we have three charges, Q1 at x is equal to 0, Q2 So we have three charges in the following arrangement. The first charge Q1 is negative and placed at origin position, x is equal to 0. Similarly, the charge Q2 is placed at position x is equal to a. Q3 is placed at position x is equal to 2a. So in order to calculate work required to bring Q3 from infinity, we will use the following equation. So now put the values here. So far we have find out the relationship between the work done to move a point charge and the change in potential energy. Now the second part is calculate the expression for potential energy of collection of point charges. In order to find the total potential energy of the system, we will use the following expression. Its further expansion will become so we're putting the values of Q1, Q2, Q3 and similarly R12, R13 and R23. We will get